So, welcome again to our webinar. The title is How to Manage Your Data Today with the latest technologies, data quality with AI and real-time analytics also with AI. So we will focus on the real cases to demonstrate what AI can do for you in these two areas. We are Avenga. We are a multinational company, IT consulting, IT services company, which is located on 3 continents, from left to right, in the United States, in Europe, in Germany, Poland, and Ukraine, and in Malaysia, in Kuala Lumpur. So welcome everybody from wherever you are. So good evening, good afternoon, good morning. We have 19 offices. We are more than 2,500 people already, with more than 350 clients and counting, and more than 20 years of practical experience. So everything that we are about to talk today is based on our practical experience and knowledge. We have a vast number of tools and technologies that we are really familiar with, that we practiced in real world projects. So we also can choose the right set of techniques, technologies for the particular business problem that we also showcase in our cases. And who we are today, I mean, who is with me today? Let's start with Olena.
Hello, everyone. My name is Olena Domanska. I am leading the data science department in Avenga. I'm located in Lviv, Ukraine. And together with our data science team, we are solving complex problems using machine learning, deep learning, natural language processing, and computer vision.
And Felix, welcome.
Yeah, thanks. Hi, my name is Felix Bahr. I'm a data scientist at Avenga. I'm based in Berlin, Germany, and I work at Wow.io, one of Avenga's products, and we use AI to classify and distinguish traffic on our customer sites.
Thank you. And Lyubomyr?
Hi, dear audience. My name is Lyubomyr Senyuk, and I'm head of R&D department. I will show you some funny stuff today.
And me, Jacek Chmiel. I'm from Avenga, Poland, and I'm director of Avenga Labs. And my role is to scout for the latest technology trends and also advise the clients about how to benefit from the latest and sometimes greatest technologies. So I hope you will find our presentation interesting. And we also would like to see your questions, feedback, comments live. The Q&A is open now, so you can ask any questions. We'll try to address those questions in our Q&A parts that will be always after our presentation of the cases. So this is the second webinar from the series of AI webinars. The first one was focused on fraud detection and natural language processing. It's available online. If you would like to watch it, you're welcome. Today we are focused on 2 very important topics: real-time data analytics and augmented data quality, of course with AI. So let's start with real-time data analytics for business. Like, what is business value? Is it some kind of hype that we should not care? No, it's something very important, because what is needed in business, especially in this digital era, is the faster reaction times, faster decisions. We cannot allow our business to not to respond quickly to the changes in the environment, changes to the business events. So we want also faster predictions to be able to predict more often and more accurately what's going on in the business, to be able to, again, to make the right decisions. And all our businesses and all your businesses are turning into always on digital businesses. Like they never stop. So this constant flow of data, and we need to benefit from this data to support the business operations and decisions. And what will happen if you don't embrace this movement, let's say, of real data analytics? First of all, your decisions might be too little too late, because you will have this latency between data analytics and actual decision-making point. So it will lead to operational latency. Decisions will be decisions will be delayed, and many trends you will simply miss, of course, especially compared to your competitors who might embrace this real-time data analytics earlier than you, or better than you. We see a huge growth of data streams, especially with Kafka and similar technologies on cloud and on premise. We have petabytes of logs from different digital products. We have billions or more events related to business events and technological events. There are many challenges in real-time data analytics. It's not easy. It's really ambitious. For instance, we should know how often we would like to analyze this data. If we do it too often with the small data window, there will be more noise, more fluctuations, less data to analyze. But when we extend this window, we will have less noise, more smoother response, let's say, but more latency and delayed, let's say, this decision time. What should be this, let's say, mini batch size? What we also have to take into account the fact that the data analytics takes time. No matter if it's real time or offline, it takes time. It's computationally heavy, and it takes time, so we also have to take it into account. So let's move on to our cases, and this is the very interesting case, and I call it once that, are you aware that the bots are eating your web application alive even when you sleep? I think you should be aware, but let Felix explain it. Okay, Felix, to you.
Yeah, hi. Thanks for the introduction. So I'm going to present the case of Wow.io. Just a few words about Wow.io. Wow.io is one of Avenga's products. It's developed and operated by Avenga, and it works like a CDN. So if you're wondering what Wow is, what Wow does, Wow has two main areas of expertise. One is to optimize loading time and performance of a website, and the other is to optimize website security. And the way it does that is, as I said, it acts like a CDN. It is placed in between a server and a customer's website. So all of the traffic that goes through the origin server of a website passes through Wow.io and on the way back as well. So the typical Wow customer is a web shop, but we have others as well. But this is what you can think of when you think of the typical Wow customer. Now, next slide, please. So on the left, first of all, you see Wow.io can provide you with a detailed performance and security report, so you can try that out on Wow.io. Now, as I said, all of the traffic that passes through Wow's infrastructure, we get log data. So each and every single request that goes through an origin server will give us a lot of log data, including client IP, user agent, the specific request path, the MIME type, so which type of document was requested, the return status, timings, and so on. So there's a lot of data that we collect. So next slide, please. So here I have listed some of the challenges. So what we want to do is, on the security part, we want to protect our customers, their origin servers, their websites. So the first point I list here, what we want to do with the protection is something that maybe you wouldn't think of as the first point. If I told you we want to protect the website, that is the excessive use of resources. And this is what Jacek was referring to when he said bots are eating your site. And this is pretty much what is happening. We see that a lot of traffic that goes through a website is in fact bot traffic. We see worldwide operating botnets. We see attackers. We see scans. And we see that a lot of this is in fact eating your server performance alive. So the server is very busy serving requests to bots, to botnets, and that might in turn lead to degraded performance, right? If your server is busy serving requests to bots from all over the world, the legitimate customer who wants to see your website might be impaired because he has to wait in line until it's their turn to be processed. Now, the extreme case of this is downtime from overload, right? If there are so many requests to your origin server that the server can't handle them all, now the server might just shut down. It might just be unable to process any more requests. And that is the extreme case, also the case of a DOS attack, a denial of service attack. Now we see that as well, where an attacker has the purpose of bringing down your site by sending so many requests that your server can't handle them. Next point is intrusion attempts. We also see that. So wherever you have a login form like username, password, we see that attackers will try to guess username, password combinations using brute force attempts. WordPress is a very common example. When you have a WordPress site and you have a username, password combination, we see that attackers will try to invade there. Now, having said that, we want to stop all of that, but at the same time, of course, we don't want to impair the legitimate traffic, right? So your legitimate users, your customers should still be able to use your site. Now, as I said, we have a lot of log data, and we were looking at the log data and saying, okay, can we identify patterns? Can we identify certain metrics, characteristics that tell us whether this is a good client, a good customer, or whether it's bad, illegitimate, an attacker, something that we want to block from the website. So we started to looking at the logs and we started identifying patterns. And then at some point we thought, hey, maybe artificial intelligence is much better at classifying this than our human intelligence is. So we started to train machine learning models, including a random forest, including neural network, all with the goal of, as I said, distinguish between good, legitimate, and bad, illegitimate traffic on your website. Yeah, so as I said, challenges are we have a lot of data, we have a lot of customers, and as I said, each and every single request leaves us with a lot of log data. So we're talking about millions of requests per hour and even more log data. And it's rather impractical because of the sheer size. This is was what Jacek was mentioning. You have so much data continuously streaming in that it's impractical to do this in actual real time. So what we have done is we have devised a solution that does this at least in near real time. And we're using a multi-step approach for this. And the idea behind that is, of course, to reduce data volume, right? So we don't want to handle millions of requests. So we pick out certain time intervals and we pick out certain interesting areas. And then we can use our detailed machine learning analysis in these smaller batches of data. So one example would be, for example, you see a sudden rise in traffic, a sudden spike. Let's say the traffic increases by a factor of 10 from 1 minute to the next. You would say, okay, maybe something is happening there. So you pick out a time interval, you pick out maybe 5 minutes around this, you run a detailed analysis, and the trained models will hopefully tell you whether this is an attacker or whether this is legitimate traffic. It might be happen that it's just an inrush of customers, so it's good. But if it's an attack happening, then we want to block the attackers and only the attackers. Now here I have brought you a couple of pictures from an actual case, and in the first row you will see just the number of requests in given time bins. And now I'm telling you that in the first row, so you see, note already that this is the second step in our approach. So here we have already singled out a single client, and we have already trimmed down and we have a limited time interval. And here we're talking about thousands of requests per minute, not millions, as I told you earlier. Now I'm telling you that one of these two request profiles was actually an attacker and the other one was a legitimate customer. And just looking at the first row, you won't be able to tell which is which. But in the second row, we've broken this down by the type of document that was requested. And the blue points here labeled delivered pages, those were requests to HTML documents. And you see that on the left, each and every single request was a request to an HTML document. That's not something that an ordinary browser does, right? On the bottom right, you see the request profile of an actual browser. And there you see that there's only a handful of delivered pages, HTML documents, and the rest were assets like images, JavaScript, and whatnot. So the case on the left was the actual attacker, and on the right was a legitimate browser. And this splitting up in terms of request type of document that was requested, this is one of the criteria that we used for determining whether this is an attacker or not. So this is a very simple picture, but this is an example of how our machine learning models work. Right, on the last page that I have brought, you see a screenshot from Wow.io's user interface, where the bots that we have identified, they are listed in terms of the incidents that we have registered by certain bots. And you can decide by hand whether you want to block or throttle or ignore this. And note that you certainly don't want to block all bots, because as are listed here, Bing and Google bots. Now, you certainly don't want to block Bing or Google from your site because you're not going to get ranked, but others you may want to block, or you might also decide to throttle a bot. So you don't block the bot from your site, but you allow only one request at a time. So the bot has to queue and won't impair legitimate traffic to your site.
Oh, really interesting. But I'm just curious, like, how did you know, like, how to classify this traffic? Like, was it done by, let's say, you as experts in this web traffic, let's say, and how the internet works, or how did you do that?
Yeah, as I said, you start looking at logs. You start to see certain patterns, and then you try to feed those into the AI models. So it's a lot about, as I said on the previous slide, knowing that a browser doesn't request 100% HTML documents, right? This is you try to understand how certain patterns work and how, as you say, the internet works, so to say, and you know, by understanding that, then that allows you to formulate those criteria with which you can train the models.
So deep domain knowledge plus smart choices in technology. So
yeah,
it's really impressive. Thank you very much. If you have questions also regarding the Wow.io and this particular case, of course, Q&A is open for you, just a reminder. And by the way, welcome to our webinar for the people who just joined. I see we have newcomers. Thank you very much for joining. Next case is from pharma. It's real-time claim resolution with machine learning. So also take a look at this.
Yeah, I will put some intro to this project. So the data here is not so huge, and actually we don't have like millions of requests here, but still the case is important to understand how real time can bring some new insights to your business, and actually can transform your business. So the task is from, actually the project was from healthcare business domain, and particularly the claim resolution. So the process when in ideal world, actually, when patient is in the hospital and it requires some service, hospital services or labs or analysis, or cover some medicine on prescription, usually it's being covered by insurance company. But the process is not so simple. So not each and every medicine will be covered by insurance company, and it is not a very quick process. So those claims are collected and then later processed, and the final decision belongs to insurance company, and nobody knows. Actually, there are some rules, but rules still can change. Insurance company can reject some claims, can cover them partially, and do similar stuff. So the task from our client was to build a machine learning model that will help to quickly understand, actually to estimate whether this claim will be covered, fully covered, and or rejected. And it doesn't sound right now as real-time process, because usually this process is pretty long. And for example, you can imagine that you are collecting some batches of those claims, and later you can quickly understand. You can, for example, estimate cash flow, so you will understand what will be covered and what cash will go to your clinic. But imagine if we will introduce real time to this process. So it may be introduced even on the level when the doctor is preparing the prescription. So the doctor immediately can communicate patient and say, look, here is a prescription that I need for you, but it will be covered only partially. Are you ready? So let's decide. Probably I can not invent, but I can use some different medicine, or we can skip this and use another. So Olena, please tell us some details about the mass underneath.
Thank you, Lyubomyr, for this introduction. So our client is a pharmaceutical company, as Lyubomyr already mentioned, and it provides some healthcare services to its clients. And they needed an automation tool for claim resolution predictions. And they already collected some historical data that we can train our models on. And they had a requirement that this model should be adaptable to industry changes. So we can't just develop a model and stay with it. We should adapt this model frequently, depending on the industry changes. So why the business needed this solution was already mentioned by Lyubomyr, but just in general, it would increase the efficiency, it would enhance the customer satisfaction level, and even quality of care. So our data science team actually developed such end-to-end system that would automatically query the data from the database, then prepare the data for model consumption, and generate and return predictions in the near real-time fashion. So in the inference phase, once the model is already developed, it is constantly monitored and retrained. Thus, the model, this machine learning system, adapts to new data. Once in a given period of time, we retrain the model on updated data, on historical data plus new one, and evaluate the model performance. If the model performance passes some predefined accuracy threshold, then we substitute the old model with a new one, just trained. So in order to build such a system, we leverage the Azure infrastructure, and in particular, Azure ML Studio environment. In the development phase, we developed the pipeline for data consumption, data pre-processing, training the model, and then registering it to Azure Container Registry. After that, the pipeline was published and scheduled in order to be retrained in some particular time with new data. Also, I would like to mention that we created a real-time inference service. So the trained model was deployed as a web service, and then the service was used to generate and return predictions. So thus, we actually achieved the goal that our client needed to provide this automatic tool for claim resolution. To you, Jacek.
Okay, and you know what also got my attention is that you use Azure machine learning services, because we know that's quite popular to use cloud services, because like all the environments are prepared and so on, like AWS, GCP from Google. And why did you choose Azure in this particular case?
Thank you. That's a really good question. And because nowadays we have a wide selection of cloud providers, including AWS, Google Cloud Platform, IBM, just to name a few. And it's actually the first question when we are building the systems like that. So in this particular case, we have selected Azure because the client has already adopted this particular cloud provider, and that was easier for our client. And the second reason was price. So Azure is known for its lower prices compared to AWS, for example.
Yeah, so yeah, thank you very much. And yeah, we have this infrastructure that you do want to
That's
elaborate
actually the
more?
architecture of the project we have just described. So we see here the pipelines, how we consume the data and then create experiments based on preprocessed data, then train the model and generate the predictions, and in the same time update and write the new model.
Okay, so thank you very much. And next case is very unusual. I think all the cases are special, but this one is less usual than usual. And it's about using computer vision for real-time series analysis.
Yeah, this one is from R&D. That's why it's so unusual among unusuals. We actually did interesting stuff here because we had computer vision task, and then we transformed this to time series task, and then we used computer vision actually computer vision approaches to analyze time series. So what was the deal? In our R&D department, we have smart camera. The camera combined with small computer that is able to run machine learning models and computer vision models particularly. And we decided to build some useful POC on this camera. And the target was to build something interesting and useful for Industry 4.0. And we decided to build a tool that will be able to identify falling objects on the scene. So imagine your camera is installed somewhere, for example, in the factory or automated warehouse, and it constantly monitors what's happening there. And if something is falling, we quickly understand that something may be broken and we need to stop the machinery and probably invite some people to clean up the mess. You see that on this animated GIF, you see the box, and box is covered with this colorful points. And actually, this is the standard technique how to find points on the edges on the screen. So we transform the video stream to some trajectories using these points. Next slide, please. Next slide, please. And each trajectory can be divided to two categories. One category is, we call this bad trajectory, so nothing is falling, we just have some random movement. And good trajectories, so something is falling or something was sliding, for example, and then falling. So trajectory contains a piece of parabola. You can also see these funny carpets at the bottom. No, those carpets. Those carpets actually is the deal because they show how a time series in general case and those trajectories in our case can be transformed to graphical form to be later fed to the computer vision algorithms. Why data scientists are doing this? One of the reasons is because computer vision algorithms are well developed as for now. They are quick. They have different topologies of neural network. The task, for example, to quickly find the template on this carpet is much easier than try to analyze combination of numbers in form of number vectors. The idea is good, but how to train the network itself? To train such networks, you need huge amount of data. And what we decided to innovate here as well, not to use real data, but generate a lot of data, lot of good data and a lot of bad data. Next slide, please. So here is actually the screen that shows how we generate good data. So we are literally throwing some objects in virtual world, and then we transform this to the plane of imaginary camera. So we built this engine ourselves because engines on the market actually are really good, but it's hard to go inside and extract the piece you need. So to render, for example, very complex screen, it's really a piece of cake because there are a lot of even open source renders, but to quickly have this actually it was easier for us to just do this transformation ourselves. Next slide, please. And here is the illustration, actually how to transform whatever data you have, for example, financial data from insurance companies or whatever, one-dimensional data, how to transform them to those carpets. Direct transformation usually doesn't work well for one-dimensional data. That's why you should use polar encoding and then build those carpets that are called Gramian angular fields. That's actually it. If somebody is interested in more details, I will be happy to answer.
I am interested, and my first question is: was anyone or any animal hurt during your experiments?
Animal hearts, no. We just smashed some boxes, and probably I don't know, developers being hurt because they during experiments they did a lot of iterations too.
Okay, my second question is more serious one. Is about this Gramian angular field, about this say digital carpet, like 8-bit. It looks like, you know, this pixelated, maybe not 8-bit. And did you analyze, let's say, static as kind of frame, or did you analyze also the say movement, like patterns of movement in dynamic, say video?
We did actually the static analysis, but it's interesting question. The methods of computer vision are rich enough to deal with video streaming as well. So if you're not afraid to go to the loop, analyze computer vision with time series, then computer vision, and then back to computer vision, we can do this.
I think it's very interesting case also because it's like not a typical combination of completely different approaches. Like also in the reverse order. Like we apply computer vision at the later stage than before, because usually we have like reverse. Like we analyze the picture and we have some data. It's kind of reverse. So
unusual.
Yeah. So that's also shows our capability to the things, let's say, out of the box. Pun intended, probably, because we have this falling box, so out of the box. And real-time data analytics. What do you think? What is next? What are the trends in real data analytics? What do you think is, let's say, hot in data analytics? Maybe let's start with Olena.
So from my perspective, data analytics takes just enormous quantities of information that surrounding us, starting from fraud detection, disease outbreaks, then some natural disasters, even traffic management, right? And data analytics tries to make sense of it. And then doctors, insurance companies, businesses heavily rely on it. And what's more important that the more critical situation is, the faster data analysis is needed. So we need really, this real-time analytics is actually critical. And what's more important that it is actually possible right now to achieve this real-time analytics. And it's due to improved analytical capabilities, some matured data science models, machine learning deep learning architectures. Also, we have access to a variety of big data sources. And as well, we see the cheaper and improved computing power. So that's why I think that in the nearest future, this demand for real-time insights and analytics will be just a norm.
Yeah, what do you think, Felix?
Yeah, I think we have seen some very interesting cases that show and illustrate that data analysis and also in real time or near real time is very important, and that there is a lot of potential value hidden in there. And the data is only ever going to get more, right? In the future, there's going to be more data to handle than there is now. And I think that's a very important case to notice, that the value for the business, for the company is in the data, and you need the real-time data analysis in order to keep up with your data, to make the right decisions in time, or else you might lose a lot of money and you might lose your customers. So I think it's very important to focus on, and also in the future that you really keep track with this.
Yeah, what do you think, Lyubomyr?
It's actually interesting aspect of real-time analytics, because besides the fact that real-time is helping us, I don't know, to drive autonomous cars, it really improves the communication between people and computers. Because people, when I'm communicating the person, I need this person to quickly answer. So this is the key of communication between people. And real-time analytics probably will introduce this to machines, and it will be easier for us to communicate them and to feel them as assistants, and actually to go to the future with ability to have really smart assistants.
Yeah, thank you. And let me remind you that we have this Q&A button. So we are welcome to ask any questions or share your views about the subject. And for instance, what do you expect from real-time data analytics? And we'll be glad to answer, glad to discuss. And what I think personally and professionally is that we also should mention this edge devices and this entire universe of edge computing and real-time analytics in milliseconds from cameras, from medical devices, from other things when there's really real-time response needed. So it's a huge universe again. What is also interesting, and it was considered unusual, but it's becoming more and more popular, is using real-time data analytics to analyze data quality, that we have enormous streams of data in B2B channels, B2C channels, and we can use these techniques also using machine learning, using pattern recognitions and similar to analyze the data when they fly, let's say, between different systems, between different business entities, and to assess this data quality. So it also can be used to make sure that not wrong data reaches the target systems. So we move to the other topic of big topic of today's webinar, which is data quality. That's a huge, enormous elephant in the room. So it was high time for us to address it. Data quality importance for business. Isn't that obvious? Sometimes it is, sometimes it is. It's better to remind ourselves how important it is. First of all, everything we do, what our companies do, requires better data insights to, again, to make better decisions. And the better the data, the better decisions as a result. So everybody wants to benefit from advancements in machine learning, this new computing capabilities of the cloud, new algorithms, new data sources, what Olena mentioned. But without good data, without high quality data, the entire initiatives may fail. And that would be kind of sad, of course. And we as customers, we expect more personalized products and services. We don't want to be treated as another gray customer. We want to be addressed personally, and it's impossible with millions of or billions of customers in some cases. So it's also very important to have good data quality for that purpose, to be able to target people with the right offer, with the right solution. So it's also very important from the sales perspective. So let's reverse this question: what would have happened if we don't have this good enough data quality? Because data is never perfect, but we are talking about making it as good as possible. First of all, it's one of the main and root causes of failures of entire data-driven initiatives, projects, programs, and it can lead to wrong decisions and serious business consequences. So data quality is very, very important, but fortunately we have multiple ways. We have entire landscape of techniques and solutions to make it better. We call it holistic DQM strategy that we use at Avenga. So first of all, data quality at the source. The source can be device, the source can be smartphone, the source can be transactional application system, line of business system. And first of all, we need to take care about this data quality at the source. So it's one primary responsibility of every system to also take care about data quality at the source. When the data starts, when data is born, let's say. Then we can apply preemptive data quality when data is moving from one system to another, from one business partner to another. We can apply this preemptive data quality checks on the fly to assess the data quality and act on this assessment output. And we have this more traditional data validation and testing on the static existing data, that we know the rules, we know how to test it, and we should do it. We should do it as often as possible, as good as possible as well. But we have also a new, let's say, kid on the block, which is augmented data quality, which is helping in the situations when we don't have data, or the data is of still insufficient data quality. It uses rules, it uses AI. We'll talk about it in a moment. What is important is that it enables data projects not feasible otherwise. It may be like the difference between project that makes sense and project that doesn't make sense. So it's really important business difference. And importance it's applied late. Sometimes we don't have any influence on the source data because it doesn't belong to us, or we cannot do anything, or it's not economically feasible to do anything at the source. So it can be applied late, but not too late to augment the data quality, to improve the data quality. It doesn't replace other techniques. I think all these techniques should be applied, and there are even more techniques than I mentioned, but it's really useful as again, and a little bit ironically, as augmentation of already existing techniques to improve data quality. And of course, our webinar is based on cases. So let's start with a very good representation of the cases about enriching data quality.
Yeah, and I'll be trying to moderate a little bit the cases, because I will try to understand why we have the problem with quality here, and why our clients actually went to the step when we should apply augmented data quality. So they have lost data quality. And our first case is address matching. And in this case, we have pretty standard pattern how you can lose your quality. So we had two data sources, and I cannot say that those two data sources had bad quality, but still, each time you are trying to combine two data sources, you will have problems with data quality, because different items will look differently in two sources. Olena, please tell us some details.
Thank you, Lyubomyr, for the introduction. So I will introduce the first case, which is address matching for enriching data quality, and just a few words about our client. And this is a digital media company connecting advertisers with the viewers. So you can just imagine the screens near the elevators in the office centers displaying some advertisement or, for example, marketing programs. And that's actually the business idea in the nutshell. So they are showing the advertisement to the viewers. And it's critical for our client to have up-to-date, accurate information about business centers, about buildings, including new offices, some reconstructions, maybe closed office centers, because they would like to know to which viewers to show this advertisement. Where are the viewers? So that's actually why the company constantly monitors and collects the data from various sources. And what is important that different sources have actually various standards for storing data. So, for example, they can have one data source can have a building name missing, or just filling the building name with the address string. And it could also happen that they would have different aggregation level. So, for example, let's imagine that one business center consists of 4 separate buildings, like in the last few lines. And in one data source, it may appear as one record for the whole business center, while in the other data sources, we would have like 4 separate records, one per each separate building. And other discrepancies, for example, missing values or different zip code standards, and so on. So the client needed a solution which would allow to resolve these text-based inconsistencies and to do it across multiple data sources. As a result of this process, the client would like to merge all the records into one master data set and make the information valuable for business objectives and business decisions. So on the next slide, we can see the challenges. As I already mentioned, it could have different name strings, including full name versus abbreviation, like street and str. We could have missing values, we could have diverse aggregations, and we could have geo-based discrepancies. So the same building name could have different addresses from the different streets if it is located in the corner of two streets. So how could we tackle such a problem? The very basic approach is just to create a list of business rules, and that will allow us to make a record linkage. And actually, for example, we can use the rules that if two records have the same address string, then we will consider them to be the same or as a duplicate. And we can do the same with, let's say, zip codes plus address strings. So, actually, indeed, it's a possible solution, like a very basic one, but it won't work for most cases, taking into account those challenges that we were just discussing. And that's why we decided to use a more sophisticated, more accurate approach, which is based on machine learning. And moreover, we decided to use the supervised machine learning approach, which is more reliable, more accurate, but it requested the training data set, because like a supervised machine learning needs something to be supervised by. And in our case, we actually need the training data set with matches and non-matches. So matches would be two records that we would consider to be duplicates, and non-matches two different records. So you may ask us, how can we collect such training data sets? That's kind of a separate exercise. And actually, that was the first step, and we did it using this rule-based approach that I just described. So we have figured out some list of rules, and based on those rules, we created matches, and then we randomly took two records with different fields, with different values of fields, and then we consider them to be non-matches. And having this training data set, as a next step, we trained the supervised machine learning, which in this case was CME's LSTM network. And as a result, we obtained this classifier, which was applied in order to provide the record linkage. So as a result, we equipped our client with good quality data, and the data that could be easily used for business decisions.
Yeah, I think it's very interesting because we have this rule-based approach, we have machine learning, but I think you also mentioned humans involved. How are still humans needed for anything?
Yes, thank you. So actually, this is not an easy task to train this classifier, because creating this diverse training data set is a challenge itself. So usually the active learning approach is used to achieve this acceptable accuracy and acceptable results. So which actually requires human in the loop, because we are training the classifier on the first iteration of a training data set, and then the human review the human reviews the results and provides some corrections. Let's say this is a match, but the machine learning model predicted is as a non-match. So the human made these corrections, and then we do the second round. So we train the classifier again on this already fixed updated data set. So, and as a result of such iterative approach, we achieve actually acceptable and good accuracy of the results.
Yeah, and I think it's also worth mentioning the let's say number of this data, because it's for this example, it seems like maybe we should set someone to sit for a couple of hours and fix it, but we know it wasn't that easy. So what was the volume of data?
Yeah, so we have several gigabytes of data in each data source. So it just wasn't possible to do it manually. We had to apply some automatic tools, and the one based on rule-based wasn't that accurate. That's why we decided to apply also machine learning on top of it.
Yeah, I think it's a great example of the, let's say, fusion of different techniques, different technologies, even using the old school biological neural networks of humans. So thank you very much for that case. Yeah, and here we have this, what you mentioned about this address matching. Yes. So.
Yeah, so I would like to provide maybe some details about it. So actually, in order to train the machine learning model, we also try to introduce a latent ID variable based on address string. And we used for this Google Places API. We just entered the address string, and we wanted to obtain the ID of that address. But it turned out that only 60% of buildings was covered by this service. That's why this feature wasn't the main one, but just one of the many features taken into account.
Yes, so very interesting case. So let's talk about another even class of the problem, which is deduplication of data, which is very common. It doesn't mean it's easy, but it's very common in many business sectors and many business applications. So let's move on to this deduplication case.
Yes, so in the previous case, we had several data sources, and we tried to merge them into one master data set. In this case, vice versa, we have one data source having a lot of duplicates. But let's just mention a few words about our client. So our client is an organization founded in the United States, and it helps fulfill the wishes of children with critical illnesses. So our client had a major problem with the quality of their data. They collected the information about donors, which could be individuals and organizations. Basically, they collected this information during 20 years, for about 20 years. And individuals were associated with each specific case. So each time they donated to the separate case, they were entered to that database. Also, it could happen that the person moved to another place, or, for example, changed the phone number or email address, and that's why that individual would be the same, but having different values of the fields. The same could happen with organizations, for example. So it could be added to the database with different names, for example, IBM and International Business Machines. So they are the same company, but could have several records. On the other hand, IBM in New York and IBM in Chicago are different instances of a branch, and they are not considered to be the duplicates. They should be separate records. So now you can see the challenges that we should tackle in order to provide this deduplication exercise. So the goal, the problem that our client asked us to help with was actually to clean the data and to figure out how many times each donor appears in the database, and then assign a master ID to the master record to know to which person or organization to which person we can contact or reach out. So again, for this task, we considered two separate approaches. The first one is just the same as we described, or very similar to what we described for the previous case. And basically, it is based on a supervised classification model. Again, we generated a training data set, and then on top of it, we trained the supervised classifier. Actually, as we already mentioned, it took a lot of time and effort. So we decided to check another alternative approach, which is unsupervised approach. So the idea was to map the records, the text strings, to a multidimensional space, and then reveal the clusters of records by looking of how close they are to each other. So the first step was to transform the text to a vector of numbers, leveraging some approaches such as word2vec or fast text, like the one that would create the vector representation of the string. And then we would use clustering approaches or clustering algorithms such as dbScan or hierarchical clustering in order to figure out the clusters or groups of such records, which would be the same actually person or organization. And by the way, even though the first approach required more efforts and time, but it turned out to be more accurate. Which is not a surprise, a big surprise, because it is supervised approach and it's known to be more accurate in general. And that's why we used this approach in production. So again, as a result of this project, we enhanced the quality of data, and it allowed our client to have more accurate marketing programs. So they didn't contact the same person 10 times in a row. Yes, thank you. I think that's it.
Okay, so I'm also curious, what was this, say, difference between these two approaches? I mean, the accuracy-wise, like more or less, what was the gap that you mentioned about?
Yeah, so it was, I think it was a big gap enough to get rid of this second approach. So it was about 10% of accuracy compared to a supervised one.
Yeah, so it's also a very interesting case, also because of using these two, let's say, popular approaches. That's one is more controllable, as you mentioned. Second one is more like exploratory and maybe more useful in other cases as well, like more unpredictable. Yeah, this is the approach.
Yeah, this is the approach with a human in a loop. So this is the approach of the classification direction when we create, so the approach with billing classifier on top of a training data set.
If think about the root cause of quality problems, what was that? Actually client, or it was independent from clients?
You mean the quality with the data? I think how they organized the data collection, because once they have collected the data, they could at that moment provide some techniques in order to clean the data and to provide record linkage in the place without putting just records as it is, and then doing this augmented data management afterwards.
Yeah, I had the same feeling.
Okay, so it's a very interesting case. So let's move on to another one about data discovery for accurate business decisions. So what decision, what data? Let's find out.
Okay, so I will try again understand why they were suffering from lack of data quality. And in previous case, we understood that probably client was guilty why data was so poor. In this case, besides the fact that actually situation it looks very similar, because this client also have a lot of data that they collected, and they actually they have the same problem, because they have some duplicates, and they some parts of data are missing in one record and in other record are not. So, but still, in this case, client is the platform, and this platform is servicing end clients that actually are producing all this data, and platform is the main aim of this platform is to process the data, and then if nobody is interested in this data, actually the platform itself also that doesn't have responsibility to store data in good format and shape and keep the same data structure, because this platform exists on the market like years and years, even before smartphone era and even earlier. And they collected a lot of data that simply is not consistent, not because of their failure, but because the nature of their business. Olena?
Thank you, Lyubomyr, for this introduction. Again, let's start with a few words about the client. So this client developed a platform which serves as the interface between the restaurants and actually the clients, the people who would like to order the food. And they launched the business long ago. It was in 2005. And you can imagine that that time the smartphones wouldn't even appear. And so the clients were sending the orders via text messages to printers from feature phones in order to order the food. And the company maintains a number of data sources about sales, about clients itself, about application usage statistics. And all that stuff is being collected for more than 15 years. So you may imagine how many data they have. And during that period of time, the company had a lot of changes in the structure of data. That's why they have a lot of issues with it. And moreover, they are serving their clients, like the chain of restaurants, and they are preparing thousands of reports for their clients every day. And many of reports have a similar structure with just slight differences depending on the department or the client using the report. So the company would like to build a scalable self-service reporting platform for the customer and employees. And just to make this scalable, because it wasn't even possible to generate this amount of reports that their clients requested. But one of the main impediments of doing it is the quality of the data. So they are dealing with some inconsistencies, discrepancies in even the city names. So for example, they can have NYC and New York City as separate records, and it's not so easy to merge them every time, and it takes a lot of time. So on the next slide, you can see other problems, including data accuracy. So they have problems with missing data, typos, anomalies, and so on. So this company asked Avenga team to perform a data discovery project, a consultancy project, in order to analyze the existing data sources and their structure, main issues with the data quality, and then provide some recommendations for the data cleansing. Actually, on the next slide, you can see what actions and what activities were performed. So first of all, we did data structure analysis. We analyzed the relationships between the tables in different data sources. We analyzed the different standards on object naming and schema design, and we provided some approach how to build the schema for reports usage so that it will be unique for all the clients. Also, we did the data accuracy analysis. We checked if the data describes the properties they meant to model. We did assessment of data values analysis, accuracy analysis. So, for example, we looked for typos, anomalies, missing data. We did data uniqueness check, so that we checked whether the data set has the duplicates in it. Also, we performed data completeness analysis. That is whether our customer has all the data needed to meet the current and future business needs in terms of machine learning tasks, such as, let's say, building recommender system, menu configuration, sentiment analysis, and others. We also did data existence check. So we checked whether all data related to time, location, and client is in the data set. So whether we don't have missing values related to those objects. And after that, we did data validity check. So we try to understand whether the data features that are stored actually are used for reports, for analysis, for example. And if they don't, why should we store them? Or if we don't have any plans for them in the future to using them. So as a result of this discovery project, we produced the deliverables like data quality report and data cleansing plan. That was the list of transformations to be performed in order to improve the quality and structure and completeness of the data.
And my question is, how did you know, like, what is the definition of correct data? Because in many data quality related projects, the problem is to determine what is the right data, and is expecting that from client is not feasible. Usually there's no like proper or accurate documentation about it. It's like, how did you go to this definition of correct data?
So we worked with subject matter experts on their site. We used metadata and just figuring out some rules. For example, if we were looking for address strings and we know that this client is within United States, so we would consider the anomalous addresses from, let's say, France. And that was our approach.
Okay. Yes, it's also very, I think, interesting because this proves that we can combine different approaches again to figure that out and do it in an organized way, which is critical for data quality. And let's move on to another case. It's about data science for enhanced information management. Sounds, and I'm curious what information, what management. So let me hear about it and let us hear about it.
Yeah, actually, it's pretty exotic case, and as usual, exotic case go to R&D basket. I will not put a lot of technical details here, but the client is very interesting, and why I want to familiarize the audience about the case. The client was startup that was working in very interesting areas. So imagine the situation when you being bombarded each and every day, and actually you shouldn't imagine the situation. Each of us is suffering from advertisement from the internet through different channels, even if we were not opted into this advertisement. And this startup had an ambitious idea just to put things upside down. They simply wanted each and every person to store their personal data, all personal data, including opt-in information about advertisement companies and other stuff, locally. but not locally in terms of locally in your smart phone or some notebook, but connected to blockchain. So it will be secured by blockchain, and you locally will be responsible for your personal data, and nobody else will be able to affect your personal data or get it without your permission. And the natural question is what actually we as Avenga are doing for them, and how this is related to data quality, which is interesting. They actually asked us to help them to convince government structures and to convince some stakeholders responsible for this to understand that data privacy in United States is really on bad situation, because as we find out, 80% of personal data can be re-identifiable using publicly available sources. What does it mean? That we simply requested some publicly available data sources. We tried to connect records from those different public data sources together using machine learning techniques. And later we understood that actually huge amount of records can be combined together, and you lack only like small pieces of information to connect even names of people or even more private information to this.
And still there are people even calling themselves data experts that think that it's enough to scramble the first name and second name, and data is going to be anonymous, and identification of the persons would no longer be possible, which is obviously not true.
Yeah, and this is really interesting topic, and I believe to the huge future for all startups that are not all actually, because some of startups that we will be most successful in those areas, like local data privacy and federated learning and differential privacy and so on.
So I think it's also a very interesting trend. So you already scratched another question here, like what are the trends for in data quality management and in data quality augmentation in particular? So let's share our views, and starting with Olena.
Yeah, so I think that machine learning algorithms will take the central stage within a company's data management strategy. So from my opinion, and it's happening right now, the machine learning models become more and more accurate and mature. So eventually they will achieve such accuracy that they will simply replace these rule-based approaches because they don't need this human in the loop, which is right now just a big disadvantage of such approaches.
Mm-hmm. Felix, what do you think?
Yeah, I think we've seen a lot of cases now where the data quality is can be affected by various factors, as we have seen. Could be on the client side, varying user inputs, user changing names or phone numbers, but it could also be on the business side, the way data is collected, the way data is processed over the years, and this will all lead to different data sets. And I think that in the future, as more and more decisions will be based on data and on how data is analyzed for the business, and if you want to base decisions on the data that you have, then it is very important that the data quality is very high and that the data is managed properly. And this, as we have seen, is not a do it once and it's fixed for all times, but it needs to be done continuously as data changes as data changes over time, new data will come in. And I think this is something that is very important because, as I said, business decisions will be based more and more on data and the way data is analyzed.
Yeah, certainly. And Lyubomyr, what do you think?
Actually, what we just said actually means that a lot of techniques used by augmented data quality probably in the future will migrate to those levels that should be before augmented data quality. I mean that data validation will be more smart, and some preventive actions regarding data quality will also become more smart. And actually, finally, we will probably don't need augmented data quality in the form we have this right now.
Yeah, and what I like about this is that finally data quality is like first-class citizen of the data project. That was sometimes something that wasn't so hard, like machine learning and other techniques. But the first and the most important thing is that all of these techniques, in my opinion, will develop, and there will be even, I think, easier a little bit, because more and more data sources are available publicly, which can be used as reference data. I mean, from governments and from other institutions. There are also new regulations that will enforce sharing some of the data. So we have more, let's say, data to play with to make the data better, to control the data quality, also to augment data quality. So it's getting better, and I think that one of the things that we attempted to inform you about is that there are multiple techniques, there are multiple technologies, there are very interesting smart approaches that we can deliver to help you with the data quality, and we don't have to just accept poor data quality and that, I don't know, be inactive about it. We can be active about it, and there are many ways to improve it on multiple points, as you mentioned. So yes, so it's like it's getting better. Maybe it's getting better slower than we would like to, but it's definitely improving in this area. So thank you very much, especially those who are still with us. I mean, it's been a lot of information. I wouldn't say data, but a lot of information in a not so short period of time. And so thanks very much for sticking with us until the end. And hopefully it's not the end, because we would like to continue the conversation. And you're welcome to contact any of us if you would like to talk more about particular data related problems related to this webinar, to other webinars. We will figure out which problem is it. Don't worry, we have a lot of experience and knowledge about it. And yeah, so thank you very much. And this webinar will be recorded for you to review later. You're welcome to follow us on LinkedIn, on Twitter. So we are Avenga, and thank you very much for your attendance here. And thanks you guys for being such a great team. And I think we could talk for hours, but we should respect attendees. So
thank you, Jacek.
Thank you very much.